All right, we are live. Should be live. All right. Give it like a second here and then I'll kick off. All right. I think we can kick it off here. This is the third episode of the Operator View, and I'm your host, Nick Swink. Today, we have an interesting topic we're going to go over. I'm going to do a short amount of slides, and then I'm going to go into some demo material. I got some interesting demo extensions and different capabilities. I looking forward to kind of doing an intro to browser extensions, but in this case, malicious browser extensions. For the slides, basically, I'm just going to talk a little bit about the ecosystem of browser extensions right now, capabilities that they have and why they're so popular for abuse right now. And then we're going to talk about them in the wild a little bit. And I'm going to show, like I said, some demos for showing some of these capabilities off. And then we'll touch on some defense for defending against malicious browser extensions in an organization. All right. Make my screen a little bigger. So the ecosystem of browser extensions right now. Chrome is dominating the space in browsers. So the vast majority of people use Chrome. That's the brand, like Chrome, not Chromium-based browsers, but the specific Chrome browser. 3.4 billion users and 65% of the browser market share. So they have a large majority of the market share for browsers. There's over 100,000 extensions currently in the Chrome Web Store, which is a lot. I mean, that's a lot. And we'll talk about a little bit why that's a problem for vetting browser extensions and what they might truly do, as well as because of the remote updating aspect of browser extensions. Total Chrome extension installations is 1.69 billion. So that stat is really just saying that most users who use Chrome or a similar browser are using browser extensions. So it's important that they vet them properly and know what they're doing all the time, especially because people can buy the ownership of a browser extension and then push malicious updates, or they could compromise the developer of an extension, push malicious updates. So for browsers, like I said, most people are using Chrome, so it has the most approximate extensions in the Chrome extension store. So around 112,000 extensions. And then Firefox is under that with like a third of that. But Firefox is one of the biggest browsers that's not Chromium based. So for all other browsers, Chrome extensions should work on Chromium-based browsers like Edge. And then you got sad little Safari at the bottom. So yeah, most Chromium-based browsers can install Chrome Web Store extensions. So Edge, Brave, Opera, they're all Chromium-based, meaning they run on the Chromium framework. So they are similar to Chrome, even though they're branded as totally different browsers. Firefox is not Chromium-based. It's actually built on top of the Gecko framework. So that one's in its own little camp with its own extensions. We should touch on Chrome Manifest v3 if we're going to talk about browser extensions, because the v2 was recently end of life. So Chrome Manifest v3 is the platform that Chrome extensions are built on, and developers had until June 2025 to transition to v3. If they don't, their extensions are no longer supported and don't work. And v3 implemented a bunch of stuff. Some things around security, some things around performance. But the biggest things for security was it implemented more granular permissions for an extension. So it split permissions into API and host permissions. So Chrome API permissions and host permissions. We're going to see in a bit what that looks like. And then it introduced background service workers. So these keep a JavaScript execution off of the main thread and run in the background as needed is the goal there for performance and security. They tried to limit execution of remotely hosted code. So like fetching JavaScript and then eval, calling like the eval function on it. It's mostly restricted. It was the goal of it. We'll see if that actually is the case. But they did away with eval, new function, remote JavaScript loading in the browser extensions. So before v3, as you could imagine, it was way more wide open in terms of security and what browser extensions might be able to do on in your browser and on your host. Yeah, so I got one more slide, I think. What can they do? So browser extensions are very powerful in terms of malicious behavior, because they can do basically everything that the user can do in their browser. So it has full access to storage like cookies, local storage, session storage. And yes, that includes cookies that have the HTTP only and secure attributes set. Unlike when you're talking about cross-site scripting and stuff like that, where it can't actually access the cookies that have, I think it's the HTTP only flag. So it doesn't allow the browser's JavaScript, client-side JavaScript to access those cookie values, but browser extensions can be, assuming that they requested the correct permissions. They can manipulate the page that you see, so the DOM. They can inject JavaScript into the active page and change what the layout looks like. They can take screenshots of tabs, and they can do a lot of other stuff. A lot of other stuff we're going to talk about, like tracking keystrokes or mouse movement. They can be there to monitor different web request activity or like fields and exfiltrate that kind of stuff. So we're going to jump into a demo now. I have a series of pages, a series of extensions created, and we're going to look at them. So I got some demo extensions, and then I have some other things I'm going to show. So I'm going to start a TMUX session, and I've got two machines here. I've got a Windows 11 host and a Kali Linux host, and they're on a subnet so that we can access one from the other. So I'm going to spin up a SMB file share here. So I'm going to call it Kali, use the current directory, and I'll show you that in a while. And then should be able to access that from here. Demo. All right, so I've got SMB share file access to my extensions, and we'll look at extension demo 1. We'll close that and open up in Visual Studio Code and take a look at the extension demo 1. So when you're looking at the structure of one of these file extensions, you could see they don't actually require a whole lot of files just to get started. So probably the most important file here is going to be the manifest.json file, and it basically defines some metadata about the extension, and then it defines the permissions and some default actions, as well as scripting. Being that this is a demo extension, it's not going to do a whole lot. It has a default pop-up action that points to this file, popup.html, which is just a basic HTML file. It's going to say this, and it actually references this JavaScript file, which doesn't do a lot except create an alert box. So, and we have to define this content scripts here. And this is just displaying that it can inject this other JavaScript file into any page if it matches HTTPS and then any domain or URL. So this shows the pop-up when we open the extension toolbar. This shows that we can inject JavaScript into any page. If we go ahead and pull up our browser, we'll do Chrome. We can go to extensions and remove that old one. And we just drag and drop, and we could see our extensions now loaded. And if we go to our extension toolbar, we'll see it here, and we see that HTML. And if we click the box, it does the alert box. So that works. And if we go to some other page, we can see that there's a red outline box. And then if we check the console, we could see that it says successfully injected into the page. So we can see that our JavaScript here is working. And this is what the border, that document body style border does. It sets a red outline. And this just console logged the message. So that's how easy it is to get going with an extension. In terms of infection vectors, I suppose you could get socially engineered into side loading the extension like this. More realistic is just these extensions are just getting approved and getting put into the Chrome store. So there's different obfuscation methods that threat actors are using, but they're just making their way into the legitimate Chrome store. Or they are benign to start with, and then they make their way into the Chrome store and then get updated with a malicious update. Updates to Chrome extensions are not scrutinized nearly as much as the initial like submission of a extension to the Chrome store. All right, let's go over number 2 here. So that was just a basic extension, didn't really do much, just showed that our JavaScript and HTML rendering of the page works. Now, this one is going to do something a little different. It's going to access form fields within a page. So same thing, injects that content.js, but now we've defined host permissions, all URLs. So it should define that it can access contents of all URLs. So in this case, our content script will run inside of the web page context, and then it will listen for the submit event and query for this specific form field. So in reality, this would only work for if a web page used those specific form fields for username, password, and things. But for the demo, we're just displaying that. You could make a more robust program that actually checked for different varieties of it. And this is the same code here. So the only difference in this one is we're displaying this capability of intercepting a submit request and selecting elements out of the DOM. So what we'll do for displaying this one is I just have a fake login page that happens to use those form fields, right? So, and then we actually need to load the extension. And then we'll open up the console just to show this. This is just because it's from a SMB share. And this should work as intended if it needs an email. And so we see this console logged to the console. But again, this is coming from the extension. So demo login attempt. And the so the extension is what is accessing these values and logging them to the console. It's not the page. So this could be any arbitrary page and it would be able to access those values. And we're just printing them for demo purposes, but in reality, they could be passed to a different web server and exfiltrated or anything like that. So that is the example I had for accessing the DOM with an extension. We can go on to number 3 here, and we're just building upon these extensions, right? So each one, I'm just trying to show like a different capability of what they would do. Real malicious extensions might do all of these things. It might do only one of these things. It's really depends on what its objective is. This one I'm going to show the background service worker. So again, this is new in the Chrome Manifest v3. You define, this is basically used to define if you want JavaScript to run in the background. It used to be done a different way that I'm not totally familiar with, but it was done through like background pages or something like that, which apparently had a really negative impact on performance. And nowadays, it's better for security anyways. So these background service scripts are defined here as a service worker. And then we define these host permissions on HTTPS and HTTP. And for this demo, I'm trying to show how you would access all browser cookies. So using a service worker, you can query the Chrome API. In here, we're showing this. We query the Chrome API to fetch all cookies, including ones with any security flags set. And then we do whatever with them. In this case, we'll just print them out. So this is on install. It will query cookies, all the cookies in the browser, and print them out. So we could try and show this one. So let me just generate. I know certain websites are going to generate some cookies. So I'll go to some of these websites, generate some cookies. My robot. Oh no, I'm really bad at this. Oh. Oh, I got it right. I guess I'm not a robot. So we were on number 3, I think. Yeah. So it will, you can see this is different. It shows the inspect view. So we won't actually see anything in the regular console from the background service worker. You have to view it in its own inspect view, which is which says service worker. And we could see it already accessed those cookies because it's on install, which we already did. So on installed cookies from the browser, and it prints them out as this big array. And there we go. We can see it accesses all of the cookies currently in the browser, no matter what tab. And looking for, I don't know if we're going to have any ones that were host only, but it will, there we go. It will get host only cookies and HTTP only. That's actually what I meant, HTTP only. So it will get those, even though, you know, like cross-site scripting and stuff won't be able to access them. So, and even then, we should also mention that stealers traditionally just would try to dump cookies and read them from the file system. Nowadays, with like app-bound encryption, they have to do some other bypasses to be able to decrypt those cookie values. But if you're executing within the Chrome process as a legitimate extension, you can just access those cookie values. So it's pretty powerful. All right. Let's go to example 4. This one, I think, yeah. So this one is the same, except I'm showing that you could remotely exfiltrate the cookies using like fetch or some other JavaScript method. So everything here is the same, except I've added this section here of code where we take all of the cookies as an array and run map and pull out the name and value of each, join them to a string with a comma, and get a count, and then submit them in a fetch get request to a URL. In this case, it's the URL. It's just the IP, a local IP here, but this could be like a remote resource. So let's see, that's correct. And we're just submitting in the URL so that we could show that it's, you know, we can capture that data basically. Now what I'm going to have to do is I'm going to have to start a web server on port 80 and then load that extension. And it's, again, the same thing as the last one, except we're just posting it to. So we printed it out. We could see them there. Again, the same thing. And then cookies exfiltrated to localhost. It's not actually localhost, and we could see this big long web request. And it has all of the cookie values. So you could set up, like, if you're doing like an offensive security operation, you could set up a web server that, parsed these cookies, in a better way. We can just grab them and like maybe put them in CyberChef or something. I think it's .org actually. Was that real? $86,000 for that domain. URL decode them. And maybe we can like split by a comma. Yeah. And we could see all those cookie values. So that's just a simple demonstration of like fetch or grab the cookies using the Chrome API and then submit them in a web request to a remote server. And let's see, what is 5? I think 5 is... Is 5 the same thing? No, 5's actually a repeat of the other one. I meant to delete this one. Okay. Now the last two I have are demo of a little bit more involved. These are a little bit more involved, these demos. So this one, I just spun this up or you threw this together with the help of Cursor in like 20-30 minutes just to try to display some of the capabilities of what you could do with browser extensions. So in this case, I'm requesting these permissions, and I have a background service worker, and it's basically going to collect information from the browser and stream the data to a WebSocket URL. And the data it's collecting is basically going to be things like tabs, what the DOM looks like, mouse movement, and keystrokes. So I could have added a bunch of more permissions to it to do other things like grab cookies and whatnot. But in this case, the goal was try to see how much you could reconstruct the page of what someone's seeing via just like a browser extension. So you could see functions here for mouse movement, scrolling, clicking, key press down. And there's a little Python server here that collects the like different inputs from the WebSocket server. It spins up a WebSocket server and streams it. So I'm going to go ahead and try to launch this. So I may have to, yeah. So I have a Python virtual environment server hosted on 000, and let me grab my IP. And there's actually a URL. So on a different page, it spins up a URL for you to view, and we're not going to see anything yet because we didn't install the extension. And then there's a WebSocket URL that we are going to put into the browser extension just for demo purposes to tell it where to point, where to connect to for the WebSocket. So I'll load this extension first, unload this other one, and then I'll load up this demo extension. Actually, I need to go into it and load just the extension file. We can see that it has a service worker. We'll just keep that open just to see what's going on. And then for the demo purposes, you could do this automatically if this was like a real tool for offensive purposes, and put in the URL, which is 8765 WebSocket. It's not what I meant to do. Let me grab the actual internal IP. And replace that 000 with the IP. Colon. I knew it was going to delete it. Save. And then our extension tells us it connected. And then we could see like it's streaming some data back, right? We'll just like type something in here for demo purposes, and we can see data coming back, and we could see our extensions streaming back live what the page looks like. I want to try to split this up to show. See if this works. No, I want to try to show them at the same time. Well, how about I do this? I'll just make a new VMware window and then throw this one over here. Bear with me. All right, this might not work out the way I wanted it to, but we can just show it like this. So we could see some of the input coming in from input mouse move and the page DOM, and then we'll show some of the key on key press. So if I do, a login field like this and submit it, we can see those key down events coming through. And what I have for this is just it dumping it to a file, which we can go into here and just look at keystrokes. So we can see keystroke events. Go like over here. Just trying to show different login pages. This one's gonna have a pop-up. Try to log into Bob Smith too many times. Doesn't like it. getting killed with the captchas today. Do I even try? All right. I'm not doing that. Log in with the phone number. All right. Reddit really doesn't like it, but the point is just showing keystrokes. So catch like that phone number or any other keystrokes. Could very well just dump cookies as well, but I didn't build that into that demo. The idea was to really just see if we could like reconstruct the page that the person's viewing without taking a bunch of screenshots, just using the DOM and loading it dynamically. Which it kind of worked out, but if you put time and effort into it, you could make it a lot better. And the last demo I have is just showing that people have been doing this kind of thing with browser extensions for a long time. There's actually a Mythic agent. So we'll go into Mythic here. There's a Mythic agent called Leviathan, and you can find it GitHub Mythic agents, and it's kind of old, but it's basically a browser extension that connects back via WebSocket to, you know, a C2 server. And so I think it was first published 5 years ago. I mean, this is like pretty old. I had to make a pull request to update it to Chrome Manifest v3. So it's relatively newer update to Chrome Manifest v3. But if you wanted to weaponize this browser extension stuff, which many have done, there's some open source stuff for offensive security and like authorized testing point of view. We can look at the docs here. It basically just generates an extension that you would then like load in some way or another. You can pass like the update URLs, which is it's like a manifest.xml document that defines where to get the update check from, or where to check for an update, and then it will update from that URL, which is how a lot of these legitimately malicious extensions are getting updated to malicious behavior. They'll be benign for sometimes months or years, and then either changes ownership or whatnot, and they check for an update. They see an update, they update, and the new behavior is tracking everything. You know, changing page layouts, intercepting credentials. They could force downloads of second stage payloads. This one's kind of a POC agent, and it basically just has a couple of capabilities. This could be, you know, extended to do a lot more. But in this case, we could see I already generated some of these sample agents. It's basically just going to give you a zip file. We'll copy it, go back. We'll copy it from downloads. And I just want to pull it over to my Windows machine. I'll disable this other one. I'll actually just extract it here. Is this what I wanted? I'm not sure. Let me regenerate it. Did that work? Okay. And copy it over. We got the extension here loaded in. So this one has a service worker too. I'll just open it so you can see the console. And then if we check back at our Mythic server, we should see this agent, which it doesn't properly show like host and IP because browser extension doesn't really have those permissions to grab those items, but we do see it's checking into the WebSocket server. So we could see just this proof of concept agent just has like some basic functionality. And again, this was actually it was made before Chrome Manifest v3. So some of these things had to be updated a little bit. Some of them don't work, such as inject. So before Chrome Manifest v3 could dynamically inject JavaScript from the Mythic server, like so you could just pass arbitrary JavaScript and load new capabilities into the browser extension. But nowadays, there's probably a way around it, but you can't do it in the way that this used to be done. We'll just show like cookie dump command. So just like we saw before, we can access those cookie values, get long JSON output with all of those cookies in the browser. And then last thing I'll show is just the screen capture, which uses the Chrome API and could get a screenshot of tabs, and I think you can get a screenshot of more than just the tab, the whole page window potentially. So that, I guess that's what the page is on. Yeah. So pretty interesting, pretty powerful for a Chrome extension to be able to do these types of things where you're running within the browser as a trusted context. So, you know, and you're on the JavaScript application level layer. So a lot of, unless browser extensions are explicitly blocked, which is a good segue to go back to our slides here. Defenses for this kind of stuff. So there's ways laid out to block browser extensions via group policy object if you're in like a traditional Active Directory environment. So you can outright block them via, I think it's a registry key, and you could just block everything and then whitelist certain browser extensions by ID, which is just a long string field. You can block them with Intune policies, and you can block them with other enterprise managed browsers like Chrome Enterprise. And I just saw Chrome Enterprise when I was looking into defensive opportunities for it, but I don't know if it's fully worth it or anything, but I think you could do a lot more with it. But it's tough for organizations to block these browser extensions because, and a lot of times they're gonna be used by users for productivity, and you don't want to stifle productivity in any way. You might get user complaints about blocking browser extensions like ad blockers and stuff like that. So you can make a list of approved extensions, and then basically you can make a list of approved extensions and then enforce that list. And I think that's probably the best way to go about it. And if you're a hybrid org that doesn't use like on-prem Active Directory with a VPN, I think Intune or whatever mobile device management program you're using, you should be able to push like a GPO. And there's probably an equivalent for Mac, or no one uses Linux as their desktop, but there's probably an equivalent for Mac as well that I'm not aware of. But that's basically wrapping up this episode's webcast. You guys can leave comments in the comment section, and I think that's going to be it for me. Shorter episode this time, but appreciate you sticking with me, and I'll see you in the next one. Bye.